go. Can you get me over her quickly? 0 to 60. And then outrun her memory. Yeah, what I really need is an open road and a whole lot of...
is the distance traveled divided by the time of travel.
Right, it's like how fast you're going.
Right, how fast you're going.
Okay.
Okay, velocity is very similar to that, except we're going to use displacement instead of distance.
Displacement.
So displacement is how...
Displacement, you guys said last time had a vector.
Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude.
A vector, right?
It's a vector,
There's
right.
direction?
Yes.
Okay. So does velocity then have direction?
Velocity does have a direction, yes.
Okay, so velocity is...
Speed with a direction.
And it's a vector.
Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah!
Right.
So is speed a vector too?
No.
Because this doesn't tell me what direction it's going. It just says 55.
Right.
Okay, so speed's a scalar?
Speed is a scalar.
Okay.
Velocity is a vector.
Okay.
Okay.
All
So,
did you know that there's some different types of velocity?
what are the different types?
Well, the first thing we can do is find an average velocity. So like let's say you're on a road trip. Your average velocity is how long it takes you to get from point A to point B.
Okay.
But it includes like all the times you stop to get gas, stop for restrooms, stop for McDonald's. It includes all that. So it's the average that it took the whole time.
Right.
Okay. And then there's instantaneous velocity. Do you know what instantaneous means?
No, what's that mean?
That means like when you look at your speedometer and it says you're going 70, like that's your instantaneous velocity.
So it's just at that instant in time.
Right.
That moment in time.
Perfect. Instantaneous instant.
Okay.
Yes. We also have constant velocity. Can you think of a time when you would have constant velocity on your trip?
Yeah, when I'm going down a long stretch of I-10 and it's just emptiness, I got the cruise control set.
Cruise control is key.
Yeah.
Yes, that is a constant velocity because it's not going to change. All right, so we have an equation that we can use to calculate velocity. You kind of mentioned it before.
Right.
And it's basically V equals D over T. Okay? So I want everybody to know what those letters mean. So I'm going to write this out. V
is velocity.
Indeed, velocity. And that is usually going to be some form of distance over time. Usually in physics, we use meters over seconds.
Right.
Okay. And then I'm going to go ahead and write down here.
Now what is D going to stand for?
D is displacement.
Okay.
Because displacement has a direction and so does velocity. But you can kind of think of it as the distance. And that's going to be in some sort of meters. Kilometers, centimeters, regular meters.
Okay.
And then T, how about you got T? What's T?
Time.
Time, indeed. And so time can be either minutes, hours, but most common in physics is seconds. And we just write an S for that.
Right.
Okay, so we're going to do some problems. Do you have any ideas about how to solve some of these math problems we're going to have to do?
Yes, we're going to use a method called GUESS.
Guess.
G-U-E-S-S-S. 3 S's at the end.
An extra S. Okay.
Okay?
What's the G?
So the G is going to be our given.
Given.
So whatever the question gives you, whenever you see a unit in the question, that's going to be your given.
Okay, our given. Okay.
U is going to stand for unknown. So that's what the question's solving for. So if the question says how many seconds, seconds is going to be your unknown.
And that's time, right?
Right.
Okay.
Okay. E is going to be your equation. So from the units that you have and the units you're solving for, you're going to be able to figure out which equation to use.
Perfect. Okay.
And then S is going to be substitute. The first S is substitute. You substitute in the numbers in your equation.
Okay.
Then you hit the next S is solve.
Okay, so that's all the math part, huh?
Right.
Okay.
And then the last S is a failsafe. It's sketch.
Do I always have to sketch if I've already got it?
You don't always have to sketch, but sometimes whenever you're stuck on a problem or if you've got a big problem, it's a good thing to draw a sketch to help you figure out how to solve it.
Okay. Yes, with 3 S's. All right, so let's do some problems. Mark Cavendish rides his bicycle for 3 hours. Okay, so 3 hours is a given, and that's our time. And over a distance of 214 kilometers, and kilometers is a distance. And in eastward direction, I have direction, so it's going to be
It's going to be a vector, so it'll be velocity.
Velocity. And the question asks, what is his velocity? So here's my givens. Here's my unknown. Oops. Sorry. Question mark. Okay. Do we have an equation that has all these things?
Yes.
B equals D over T. Okay. And then it's already rearranged.
Mm-hmm.
So we can just put our stuff in. 214 for D, 3 hours. We divide that out. And we get 71.3 repeating. We can round. That's okay. 71.3. And I have my units right here. Kilometers per hour. All right, Miss Anderson.
Use the triangle.
All right. So if this is not working for you, you still have to do givens, unknown, and equation, guys.
Once you figure out your equation, you can plug into a triangle.
Okay, so now here's our triangle. This is on top.
D is always on top.
Stays on top. Sorry, that's kind of a weird D. Anyway, and now I'm going to plug in 214 and 3.
You're solving for V.
So I'm going to divide, and I still get 71.3. Go back to my units. It was kilometers over hours. So either way, same solution, huh?
Yes, ma'am.
Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah!